So if the second order ODEs, ordinary differential equation, is given, we know how to change that into a pair of first order ODE and then solve that. Okay. So what I'm going to do next is I'm going to give you one example that has a second order ODE, and you will change this into the first system of first order ODE, and you solve that, and then you find out the solution of that system as well as the solution of the second order ODE directly. Okay, because this second order ODE has y in it, right? And then you want to find the solution for y. Okay, and then you will plug in back and then get the solution for y, and then you will do the direction field and phase portrait, and also classify the critical point there. Okay, meaning the whether it is stable, unstable, what type of critical point is that. Okay, all right. So to solve this, first of all, we want to change this into the pair of first order ODE. So what we do here is let's say x1 equals to y, and then x2 equals to y prime. Okay, so if you do that, then so what will be the x1 prime? X1 prime will be y prime. Okay, x1 prime will be y prime. That will be just x2, right? And how about the x2 prime then? So x2 prime will be y double prime, right? So if you solve this for y double prime, you'll get negative 7y prime plus 10y. So this is same as equals to negative 7x1, sorry, x2, okay, and then plus 10x1. You see that? So how do you put that into the matrix form then? So let me first write down the equation. So what you get is x1 prime equals to 0 times x1 plus 1 times x2. You can write the first one like that. And then x2 prime equals to 10 times x1, right? Oh, by the way, this should be minus, right? So negative 10, this should be negative 10, this should be negative 10, right? So negative 10y and then negative 10x1. So negative 10x1 minus 7x2. All right. So let us write this in the matrix form. So you can write x prime equals to a times x. But what is a? Where a is where a is equals to 0 and then 1, right? And then negative 10 and then negative 7. Okay, so to find out the solution of this system, okay, this system, we need to find out the eigenvalue. That's the method that we learned, right? So to find out the eigenvalue, we need to find out the characteristic equation, right? Characteristic equation is you get lambda squared minus the sum of the diagonal elements, so negative 7 lambda, right? And then plus the determinant will be what? 0 times that is 0 minus 10, negative 10 times 1 is up, so that will be 10 equals to 0. See that? So what are the eigenvalues then? So the eigenvalues are, so basically let me simplify this. Lambda squared plus 7 lambda plus 10 equals to 0. So you can write lambda plus 5 and then lambda plus 2 equals to 0. So lambda equals to negative 5 and negative 2. Okay, that's what you get. All right, so what is the, now we need to find out the eigenvector for each eigenvalues, right? For lambda equals to negative 5, what do you get? So you get a v equals to lambda v, where v equals to x1, x2, let's say. Okay, so what you get is a is 0, 1, negative 10, negative 7, and then you do x1, x2, right? And then equals to negative 5 and then x1, x2. Okay, so what you get here is you get x2, so 0 times x1 plus 1 times x2 is x2 equals to negative 5x1, and then this will be 10x1 minus 7x2 equals to negative 5x2. That's what you get. Okay, so it is, I mean, whatever equation you take, you should get the same equation at the end, right? So let us take the first one. So what you get here is x2 equals to negative 5x1, right? So if you take set x1 equals to 1, what do you get? If you set x1 equals to 1, x2 will be negative 5, right? You get x2 equals to negative 5. Hence the eigenvector v is, you can say v1, okay, because this is for the first eigenvalue. You can say lambda 1 equals to 1, negative 5. So this is the eigenvector for the first eigenvalue. Again for lambda equals to negative 2, what do you get? You get AV equals to lambda V, implies 0, 1, negative 10, negative 7, and then x1, x2, and then equals to negative 2, and then x1, x2. You see that? So this will become x1 equals to negative 2x1, right? And another equation will be negative 10x1 plus 7 minus 7x2 equals negative 2x2. But you don't have to do both, okay? So just take one equation and set, set this is x2, I'm sorry, this is x2. So set x1 equals to 1, you get x2 equals to negative 2, right? So what is vector v2? It is 1, negative 2. So the general solution, general solution is, what do you get? You get vector x equals to, basically, you know what, you can basically find out what is the solution here. Vector x will be, you can say that e to the negative 5t and then 1, negative 5. That is the solution of the first for the first eigenvalue. And for the second eigenvalue, you can do x equals to e to the negative twice t, and then you get 1, negative 2. That's what you get, right? Now if you find out the Wronskian of these two solutions, you will get non-zero. That's why we can say that these two solutions are the fundamental sets of solution. So the general solution is the linear combination of those fundamental solutions, right? So it will be c1 and then e to the negative 5t and then 1, negative 5, right? And then plus c2, and then you can find out e to the negative twice t, right? And then 1, negative 2. That's what you get. So this is the solution for x1 comma x2, right? But you need to find out the solution for y, because your given equation is given for y. So what is y then? Y is same as x1, right? So y equals to x1, which is equal to, you will pick the the top number, right? So it will be c1 e to the negative 5t plus c2 e to the negative twice t. That's what you get. Okay, that's the value of y, or same as x1. This is our equation, right? This is the system, right? This is the system. So what is the what is the equilibrium point of this system? Equilibrium point is just 0, 0, right? So 0, 0 is the only equilibrium point, right? And then to check the stability, what you can see from here is, since the eigenvalues are both negative, then 0, 0 must be stable, right? So the 0, 0 must be stable. Also, there is another way, right? So as t tends to infinity, what happens? This will become 0, right? This will also become 0. Why? Because if t tends to infinity, you will get e to the negative infinity. E to the negative infinity always go to 0, and there also you will get e to the negative infinity. So that will also go to 0. So you get that y goes to 0, right? So you can see that 0, 0 is stable. So 0 is stable point, stable equilibrium point. But if you want to draw the phase portrait, so it is x1 prime equals to x2. That will be just y, right? And x2 prime is negative 10x1 minus 7x2. That will be negative 10x minus 7y. You see that? This is what you get. Okay. So see, so everywhere it is going like, if you start from any point there, it is going to 0. You see that? So wherever you start, it is going to 0 anyway. Okay. So meaning that 0, 0 is a stable equilibrium point. All right, guys. That's what you can see. So so you see that also if you want to plot the solution y, you will see how that the graph of y go to 0. Okay, but the thing is here c1 and c2 are not given. Okay, and then you will have to assume, but for any c1 and c2 that is a finite number, you will see that the graph of y equals to that function will go to 0. Okay guys, thank you.